Assalamualaikum. My name is Hazwan Arif. I will be representing from my operating system group assignment. I will explain about Deadlock. What is Deadlock? Deadlock is a permanent block of a set processes that compete for system resources. In other words, process is blocked and unable to proceed. In this video, my group and I have done research on Deadlock that is in safe state, and you will see two questions on it. Okay, let's start by doing the algorithm for Deadlock. We are going to use Banker's algorithm for the safe state. Both safe state and unsafe state uses the Banker's algorithm. For question 1, I will explain more detail than question 2 because it is the same process and calculation as question 1. Let's start with question 1. This is the total resources that have a total instances respectively. A have 11 instances, B have 16 instances, C have 14 instances, and D have 18 instances. Every question has the allocation table, maximum table, and the available table. This is the allocation table. Each process have their own instances for each resources. Let's start with P0. It has an A 1 instances, B 0 instances, C 0 instances, and D 4 instances. For P1, it has an A 0 instances, B 4 instances, C 2 instances, and D 2 instances. For P2, it has an A 3 instances, B 0 instances, C 1 instances, and D 2 instances. For P3, it has A 2 instances, B 2 instances, C 1 instances, and D 0 instances. For P4, it has A 1 instances, B 6 instances, C 3 instances, and D 2 instances. This is the maximum table. Each process have their own maximum instances for each resources. For P0, it has an A 1 instances, B 6 instances, C 5 instances, and D 6 instances. For P1, it has A 2 instances, B 4 instances, C 5 instances, and D 7 instances. For P2, it has an A 4 instances, B 0 instances, C 1 instances, and D 2 instances. For P3, it has an A 2 instances, B 7 instances, C 5 instances, and D 0 instances. For P4, it has an A 0 instances, B 8 instances, C 5 instances, and D 2 instances. On my left screen is actually the reference for the calculation that we need to do. I have already highlighted each processes with each instances. Next, we have the available table. Resources A has 5 instances, Resources B have 4 instances, Resources C has 7 instances, and Resource D have 8 instances. Okay, next we need to calculate the need table. To calculate the need table, you need to have the maximum minus the allocation table. This is the need table after the calculation has done. Now I will show you how to calculate. For process P0, take the process P0 in the maximum table, then minus the P0 allocation. For process P0, take the max of P0, that is A1, minus allocation of P0, that is A1, equals to 0. Next, B for max is 6, minus allocation 0 equals to 6. After that, it's the same calculation. I'll fast forward it and hope you understand clearly. Next, to calculate if the process is really in safe state and don't have a deadlock, we need to calculate the execution safety algorithm. To calculate it, we need to see if the need table is less than or equals to the available table. We start with process P0. Take P0 in the need table and compare with the available table. Is it less or equal to the available table? The answer is false. Okay, if it's false, we leave it first and go to the next process. Next, P1. Compare again the process in the need table and compare with the available table. Is it less than or equal to the available table? The answer is true. If it's true, it has an additional step to it. You need to add the allocation table for process P1 and add with the current available. Now you will have a new available. Next, we do process P2. Same step again. Compare the process in the need table and compare with the available table. The answer is true. Now add the allocation table from process P2 and add with the new available. And the answer you will get will be the new available. Same process and step. I'll just let you guys see and understand. After finish executing process P4, has it finished executing the processes? The answer is no. Process P0 is still false. You need to compare it again with the new available. The answer will be true. And the same process for adding the calculation for P0 will be the new available. You will get the same answer as your total resources instances. As you can see here clearly, so the conclusion is that the system is in the safe state and there is no deadlock, and deadlock can be avoided. The safe sequence for question 1, process 1, process 2, process 3, process 4, and last but not least, process 0. That's for question 1 answer. So hope you guys understand for question 1, and now we'll continue for the second question. Now we go to the second question. Same step and calculation but different type of question. I will go fast in explaining the second question. It is really the same process of calculation and step to find it, is it in safe state or unsafe state. For second question, we have the total resources of the instances are A, have 3 instances, B, have 4 instances, C have 12 instances, and D have 16 instances. We have the allocation table here as you can see. You can pause this video if I'm really too fast. Next, this is the maximum table and the available table. Again, on my left screen is my reference to the second question. Now, we can calculate the need table. To calculate the need table, take the maximum table of each processes minus the allocation table of each processes. I have done the calculation for it. You can pause the video to see more clearly and you can see my mouse that clicked on the screen. Okay, next we need to see if the processes is really in the safe state by using the execute safety algorithm. The step is to compare the need table and it must be less than or equals to the available table to be true, and if it not, it will be false. We start for process P0. You can concentrate on my mouse pointer to make you guys understand more. Again, I will go fast in this step. This is a repeating step and calculation just in question 1. If you guys still don't understand to calculate the execute safety algorithm, you need to refer back to question 1. Since P1 is false, we need to calculate again and compare it with the new available. Now it will be true. The answer you will get for P1 is the same as the total resources of the instances. So, the conclusion is that the system is in safe state and therefore deadlock can be avoided. The safe sequence for question 2 is process 0, process 2, process 3, process 4, and process 1. That is the step and the calculation to find whether both question 1 and 2 are in safe state or not. Indeed, it is in the safe state and deadlock can be avoided. I would like to thanks to my team member who cooperate in making this video possible. Hope you all understand what I have been explaining in this video. I wanted to say sorry if it is not a good video for explaining this deadlock in safe state. Hope you don't mind. Last but not least, if you enjoyed this video, give it a like and subscribe to me. I am Hazwan Arif signing off. Thank you and bye bye.